Kirk Math. All right, here we go. We are on the last lesson of Module 9 and Module 10, 10.3, where we are going to make connections between transformations and similar figures. So the first thing you got to do is take some notes on our key terms. Our first or only key term in this is what a similar figure is. So similar figures have the same shape, but they can be different sizes. So as long as it's at the exact same shape, which means that it has the same proportions, okay, then I know that it is a similar shape. Having the same proportions means that the ratios are the same, okay? So if this side of the house is 4 and this side of the house is 1, then this side of the house might be 8 and this side of the house might be 2, right? So everything is in proportion and they're all going to have the same ratio, which is that scale factor. Okay, so similar figures have been dilated, basically. They have the same proportions, they have the same scale factor. The difference between similar shapes and congruent shapes is this. Similar shapes are stretched proportionally. They have the same shape, but different size. And congruent shapes have to be exactly the same. They're basically the same shape, but they are turned, flipped, rotated, slid. They are just identical. They just might not be facing the same orientation, okay? So here's the key, is similar has different sizes, whereas congruent is the same in both. All right, so we're going to do this lesson very similar to the, I believe it was 9.5 in Module 9, where we're going to go ahead and go through a list of transformations, including dilations, moving this rectangle around, and see what happens, and then we're going to talk about it, and we're going to talk about how these shapes are similar but not congruent. So we're going to start here. Now remember, this rule, anytime I'm adding or subtracting to x or y, it is a translation. It means I am sliding my shape up, down, left, or right. Okay, so I'm going to take all of my points of my shape and I'm going to slide them 7 on X and 2 down on Y. So to the right 7 and to the left 2, and down 2. So I'm going to solve these first with its rule, and I'm going to apply them to the X coordinate. So when it says X plus 7, that means I take all of the X's, all of the X values of all of my points, and I'm going to add 7 to them. Then I'm going to take all of the Y values of my points, and I'm going to take away 2. So when I did this first one, -6 plus 7 is 1, and 8 take away 2 is 6. Now I can double check that by actually counting. Okay, 7 on X, 1, 2, 3, 4, 5, 6, 7. And down to 1, 2. So that's going to be my new point. And if I check my work down here, it should be at 1, 6. And I'm right, 1, 6. There we go. So I'm going to do the rest to these ordered pairs right here. I'm going to do -6 plus 7 again, which is going to give me 1. 6 take away 2 is 4. So my new point should be 1, 4, 1, 2, 3, 4. And then I'm going to do it here. -2 plus 7 is 5. 8 take away 2 is 6. 5. 1, 2, 3, 4, 5, 6. And then the last one, -2 plus 7 again is 5. And 6 take away 2 is 4. So 5, 4. So there is my new shape right here, and this shape, whoopsie, is called A. So now the next thing I'm going to do is this rule right here, and if you go back to your rules on topic or module 9, you'll see that if I'm just changing the Y, That means I'm reflecting over the x-axis. I want to take all of my values, and on the y's, I'm going to change all my y's to be the opposite sign. So positive y's are going to be negative, and negative y's will be positive. So I've done all of that in my light blue here. I changed all of my signs, and I'm basically flipping this over the x-axis. So I'm going to go ahead and reflect this over. So I'm going to get a point here, here. Let's see. 1, 2, 3, 4, 5. So I need to go 1, 2, 3, 4, 5. And here. So this is my new shape, B. Okay, and now we're going to rotate 90 degrees clockwise. So let me look at my notes and figure out what rule that is so that I can apply. So a rotation 90 degrees clockwise about the origin is going to be 1 coordinate to the right. And this is my rule right here, y minus x. So I'm going to go ahead and apply that to B. So I'm going to flip-flop my x and y. And I'm going to make the original x the opposite sign. So I'm going to take my blue thing here, and I'm going to apply that rule, and then we'll plot our points. Okay, so you can see that I flip-flopped my -6 and my 1 over here, and I made the original x the opposite sign. So my new point is -6, -1. So I'm going to plot my points. So here I have taken B and rotated it 90 degrees clockwise, and so now we're going to go after D. So on D, we have another slide, another translation, where we're going to slide it to the right 5 and up 3. So we're going to go to the right 5 and up 3. All right, so I went ahead and slid this over 5 and up 3, and here is shape D. Again, if I wanted to do that to my points, I'm just going to add, I'm going to do it kind of over here. So I would have taken the -6 plus 5 and the -1 plus 3, and that would have given me -1, 2, and that's where my new point is. Now I'm going to go ahead and do E. Now E is our new one where we're going to dilate, and we're going to multiply everything by 3. So I'm going to take my new points here of D. Okay, I'll probably erase this and clean it up a bit. I'm going to rewrite my new points for D, and we're going to multiply everything by 3. All right, so what I did was I multiplied every single coordinate by 3, and I got my new points here in red. So -1 times 3 is -3. 2 times 3 is 6. 1 times 3 is 3. 2 times 3 is 6. -1 times 3 is -3. Negative, right, and so on and so forth. So now I'm just going to plot those points to make my larger shape. So -3 and then up to 6, which is going to be in here. Nope, that's 7. This is going to be 6. And then I'm going to have +3, 1, 2, 3, 6. And then I'm going the other way, 1, 2, 3, and down to 6, and 1, 2, 3, and over to 6. So this, 1, 2, 3, whoops, this right here is my big dilated shape, and this becomes shape E in red. It's kind of hard to see. All right, so here's our answers, but a little bit more neat and organized. And we are going to use this to answer our last question, which is we're going to compare the original green rectangle here to rectangle E, which is our big transformed dilated E rectangle here. Okay, so we're going to compare the shape, the size, and the angle measures. Okay, so the shape, well, we started with a rectangle and we ended with a rectangle. So the shape is the same. It's a rectangle. Okay, the size, here we had a 4x2 rectangle, and in the end we have 1, 2, 3, 4, 5, 6. By 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have a 6x12 rectangle, so our size has increased. We have an enlarged shape. Okay, its scale factor, if I do little side to little side, so my new side was 6, my old was 2, that's 3. My new side was 12, my old was 4, that's 3. So my scale factor is 3. So we times our shape by 3. And we also know that if we go back in the rules, you'll see that it was 3x and 3y. And then the last part are my angles. Now I know that because this is a rectangle and it's on the coordinate grid, I know that all of my 4 angles are 90 degrees. And because of that, I also know that all 4 angles of my new rectangle are also 90 degrees. So they have the same 90-degree angles. So even though they have been enlarged, their angles are the same, okay? So the shape is the same, the size is not the same, it's enlarged, but the angles are the same. So that is how I know that these shapes are similar and not congruent. Okay, now on this next one, we don't have a picture to go off. We just have rules that we have to base what happens to my figure of. So it says, describe what happens to a figure when the given sequences of transformations is applied. So I can tell that here I am reflecting a shape because my x and y stay in the same spot and only one of my values is opposite. So here they first reflected over, and then remember the one that changes is the opposite of the axis that it flips. So because x changed, I'm flipping over the y axis. Okay, then we are going to go over here where we're looking at 0.5 times x. That is multiplying by a half. So I know that that was a dilation, reduction, because I'm going smaller. If it's a fraction or a decimal, it's a reduction of 0.5 or 1/2. Okay, and then the last thing that happened to my shape, let's do an interesting color. Okay, is here, and this is going to be a translation or a slide. We're going to translate to left and to up. Right? Okay. Anything that's on x is left or right. This is negative, this is positive, and anything that's being added or subtracted to y is up and down. This is positive, this is negative. And so this is what's happening to my shape. Now I could form a complete sentence and say something like my shape is being reflected over the y-axis. Then it is becoming a reduction through a dilation of 1/2. And then it is translating 2 units to the left and 2 units up. Okay, so we are going to figure out how to get shape A, which is down here, this little blue guy, to be in the same size and shape as shape B, and we need to tell if they're congruent or similar. So what I did was I went ahead, I realized that shape A is definitely smaller than shape B. It's a 2x2, whereas shape B is a 4x4. So I found the scale factor by dividing my new image by my old or my original. And that's how I got my scale factor of 2, and that's how I wrote this rule right here. Then once I dilated that, then I counted how many slides and in what direction I would need in order to get the shape to be where B is. So we went over to the right 4 and up 6. So my rule is x plus 4, y plus 6. Okay, and then that is how I'm going to get my shape here. And because I had to dilate, my shapes are similar because they are the same size, or sorry, they are the same shape, but not the same size. And then the last thing I'm doing is if I have a shape, and it doesn't matter what shape, but if it has been dilated by a scale factor of 4, and one side is 4 inches long, then how long will the image side's length be after the dilation? So if I start with a 4 and I'm dilating by 4, I'm just going to do 4 times 4, which is 16. So my new, well,